Hey everybody, and welcome back to another video in this series. So we are finally now getting into the parts where we get to look over the motion matching node, the pose history, and all the stuff that is linked within the motion matching node. So I hope you're excited, because I know I am, because this is actually pretty cool how the inner workings are. I'm still roughly going through the inner workings of the motion matching node. There is a couple parts that I'm struggling to find just because they seem normal, but when you try to get them, one of them being the blend stack input, I just for some reason cannot find how to do that anywhere. So I'm still going in through that, but the other stuff that I've researched in the motion matching node is pretty cool and how it is like applied to certain things and whatnot. So I'm excited to get into that in later videos, but in today's video, what we are going to be specifically looking at, and I'm going to pull it over, is we're going to focus on making the motion matching node, or at least setting up the motion matching node. We're going to be creating this function, and this function, as well as another one that is, I believe, used in I think this motion matching node. And then we are also going to be taking a look at this pose history and how it's set up and stuff like that. So that's going to be really cool. And I do want to preemptively apologize to everybody. I have been being attacked by allergies lately, so if you hear me sniffling or like trying to clear my throat and whatnot, it's just like that's how bad it's getting. So I didn't want to delay these videos, but I had to kind of, yesterday and I think the day prior, just because I just wasn't feeling well. So since I'm feeling better, I'm gonna try to do this this part for y'all. So let's go ahead and get started and get right into it. So the first things we're gonna grab is, let's go ahead and grab the motion matching node. So with the motion matching node, this should become available when you have done the pose search plugin. So that's why you'll see when we look up motion matching, we strictly want the pose search motion matching node, because this is what we're actually going to be setting up. Then over here, so we're going to leave that for the moment because we are going to come back to it. But real quick, what we're going to do is we're going to quickly set up the pose history node, and we're going to take a brief look at it just because it is a pretty simple thing to set up. So what we're going to do is we're going to right click into the graph, and we're going to look for pose history. And we're going to get this pose history node underneath the pose search. So when you see it, it looks remotely similar to the one that's in the game animation sample project. However, you may notice that it's like it just has a trajectory and not the one that we need, or how they have it in the game animation sample project. But to add it, all we're doing is we're going to click on the pose history, and right here where it says trajectory in the details, we are going to pin it to the trajectory variable that we had created here in the event graph when we did our generate trajectory. Because what this is trying to do is, so if I read off the game animation sample project notes that the devs left behind, is that this node specifically is the second motion matching related anim graph node that is critical for motion matching to function. This node contains a reference to the trajectory, or optionally generates the trajectory itself, which is needed in order to match animation data against it, as well as a cache of previous pose data, which is also used by the motion matching query that is set up right here, because it is a query trajectory type. So this node contains settings on how often poses are collected, how many previous poses can be stored, and a list of bones we want samples from. So basically what we want to do now is we want to briefly go over it. So what we're trying to do is we're going to keep the pose count at 2, because that's the amount of poses it wants to store ahead of time for our motion matching query to work. And there's no sampling interval, meaning so what they have it set is set to 0, so that way, as you can see here, it will collect the information, or the the amount of poses that we want every update. So basically this should be happening like every second, right? So now what we want to do is, they have 6 bones that they want to collect data from. So what we're going to go ahead and do is we're going to add 6 array elements just like that. And what they're doing is, in here, what they grabbed first was the foot right, so foot R, because we want to collect bone data from the foot R, and then the other one would be our left foot, just like that. And then what we want is the right thigh, and then left thigh, and then the spine of 5. Oop, not 05, 05. Just like that. And then the pelvis. So basically what it's trying to do is it's trying to gather as much leg data as possible within our, generated trajectory values. So like when you go through here, how we went through the generated trajectory is how it's basically, calculating or getting samples of like the past 30 to predict the next 15. And then it's looking for collisions that are ahead of it when, you have that trajectory line that you've probably seen in other motion matching tutorials. And it's like, so it's generating a, that line ahead to see if we come across any collisions. And then it sets up with our trajectory of like future velocity and other stuff. So, that was back in, I think, the second or third episode when we went over all this stuff. So that's what it's essentially doing. And so in here with the pose history of that trajectory information, we strictly want to get, our lower half of the character, in order to get a pose count or like 2 of the poses that it's going to do or in the future. And then it's going to update those poses every second, that's why we set it to 0. So like literally every second or every frame that it's going through, it is just going to collect the data on every update. So that's what it's doing there. So then what it's also doing is we have a root bone recovery time where, it says time in seconds to recover the reference skeleton root bone from any eventual root bone modification. If 0, the behavior will be disabled. So all it's trying to do is it's trying to just get a recovery with its root bone, because it's how it's a little offset, and that's why this is under experimental, and that's why we have other things going through like offset root bone and other stuff. So basically what it's trying to do is just like have a recovery for the root bone for like its pose history data. It was a bit weird when I was like going through it and reading this, but that's I want to say the best way I can explain it. So it is kind of weird. But what they have it as in GASP for the seconds though is 0.3, because they want to try to because like it said here, if it was 0, that it was disabled. But when we give it a little bit of time, it manages to recover basically every 0.3 seconds that it recovers that root bone. So, other than that, the only other thing that they have is that they gave it a tag of pose history. Just like that. And then that is pretty much it. And so this is now actually fully set up. So what we're going to do is, now that we have that, we are going to then plug in our source and then plug in our pose history into the output pose. And then we are going to now copy the dev note and place it in here, because we are now officially done with this pose history node. So now we can spend a lot of our time focusing on the actual major motion matching node, which is, up at the beginning. However, just to briefly go over what this does in a more simplified form, is that, it's doing trajectory tracking. So it references, generates the character's movement path trajectory needed to match the animations, that it's collecting via its pose count of 2. And this is being retrieved in the generate trajectory function. And then what it's doing is, caching the previous poses to help find the best animation match. And then we can adjust how frequently poses are collected, how many past poses are stored, and which bones to sample. So that is essentially what it is doing. So that is the more simplified note that I have here as far as what it's doing. So now we get to finally get into the nitty-gritty with the motion matching node, because now we're going to be separating it into multiple parts. So in this part now, in this video, we are now going to, go over it, and we're going to go over the notes that the dev left and the functions. So let's just quickly go ahead and go over what the devs had left, and then I will briefly explain what they mean by that, right? So let me bring this over. So what we have is that the node is a primary, AnimGraph node that drives pose selection in a motion matching system. The motion matching node requires two key components, which is a pose search database, which contains the animation data the node will use to make selections. Additionally, the pose search database assets use a pose search schema asset, which defines what pose and trajectory data is used to make the selection. So basically what it's talking about here is if we go into content, characters, the UEFN mannequin, animations, and motion matching data, it's really much talking about these databases that are set up, with dense, sparse traversal, and then, the schemas that they use when, trying to make up that data or utilize the databases, right? So then we have the pose history node that we just discussed, which contains the pose and character trajectory data that will be used to query and match animation data against. So in this example setup, the pose history database asset is set in the update motion matching function, which can be viewed in the node's details panel on the onUpdate properties. So basically, if we go to it, it's referring to this specific function. So in addition to the required inputs, the node has some additional notable features. On motion matching node, you can use the blend time float input to dynamically change the blend time. This can be helpful when different kinds of animations need to blend at different speeds. In this example setup, the blend time input is set using the blend time function, which is the get motion matching blend time, which we will be making in this video. So the motion matching node also has two anim node functions that are applied to the node. On update, which calls the update motion matching function. On motion matching state update, which calls the update motion matching pose selection function. The update motion matching function is evaluating a chooser asset, so it's basically our chooser table that we're going to be setting in there, and outputs an array of motion matching databases. This allows us to separate our locomotion data into multiple databases and allows the chooser to filter the pool of animation data the motion matching node can search in any given frame to only relevant animations. This implementation can increase both your control over the final selection and reduce your project's performance cost. The update motion matching pose selection function allows us to perform additional logic based on the result of the motion matching selection. In this case, we cache the database the selected animation is in, so that way we can grab any tags it has, which can be used for future selection logic. These tags are grabbed in the event graph due to the thread safety issue, so see current database tags. So with that being said, the basic gist of what they mean by all that is that, so the components that we require to make sure that motion matching works is that, the pose search database, which we store the animation data and use a schema to define how pose trajectory data is matched. And then the pose history node, which tracks the character's recent movements and compares them with the database for the best match. So, in the details panel, the pose search database is assigned through the update motion matching function, and the blend time input lets you adjust how smoothly different animations transition, and it's set dynamically via a get motion matching blend time function. The key functions, so on update runs the update motion matching function, which filters animations using a chooser asset to keep only relevant data, improving performance. On state update, it uses update motion matching post selection to cache the selected animations database and tags for future use. So now that we got that out of the way, so let me go ahead and put that back over and we can get started into this, or started doing this. So first thing we want to do is within our motion matching node, we do want to expose this database as a pin, because it's going to be, or uncheck it as a pin, because what we want to use is we don't want to set a database, so we want to remove it from being a pin, because it's going to go through its database, from the chooser table, strictly this one. Let me find it. Strictly this one from the choose your table pose search databases. So it's when we go through it and actually make the functionality inside, this is what it's going to be using to then get these chooser tables to then get these databases. So now what we're going to do is for the pose reselected history, we're going to keep it at 0.3, and so this prevents reselection of poses that have been selected previously within this much time. So after 0.3 seconds have passed, it can reselect the relevant pose history. So then as far as that, everything else is pretty much kept on default, where we have reset on becoming relevant, where it resets the motion matching database when it's relevant. And then the should search, which, you know, what it does is it allows, this is useful if you want to stagger searches of different nodes for performance reasons. So that's what this is doing right here. And then what it also has is should filter notifies. So as you can see here, it flags to determine if it notifies from originating from an anim player, samples should be filtered out or not, which is basically, if I go back to it, should be under characters, you have animations. There is I believe it's probably in blueprints. Yeah, right here, the anim notifies. Basically, it filters these out. So that's what it's doing there. And then the store blended poses. So this is where it utilizes the pose history. So it stores like those poses. So if the number of requested blends is higher than the max active blends, blend stack will blend and accumulate into a stored pose all the overflowing animations. If the Boolean store blended pose is false, the memory to store the pose will be saved, but once reached the max active blends, blend stack will start discarding animations, potentially resulting in animation pops. So this just allows us to store blended poses, you know, during other processes, like, you know, for example, when we discussed the default slot node, where it does montages on how it accumulates and stores data. That's essentially kind of like what this does, like during those kind of events that fire off. So other than that, what we also have is the max blend time and override. So if the most relevant recently added animation is within the max blend in time override animation, the new requested blend will take its spot. Otherwise, a new blended animation will be added to the stack. This is set in the game animation sample project as at 0.03. So every 0.03 seconds, it will override those animations. And then for the player depth and time multiplier, the anim player's blend in timer will be incremented, and player depth multiplier times by the player multiply blend in time multiplier for you know, a faster or deeper blend. It was kind of a mouthful. I just kind of messed that up a little bit, but that is pretty much it as far as the basic setups, as far as what they are using for the motion matching database. However, they do have, I didn't mean to zoom in like that. If I go back to here, they do have a blend profile, and I did not do the blend profile for the, I believe it was the blend poses by Bull for the fast head weight. I did do that in here, and basically what you would be doing with this is to set a blend profile. You would go to the SK mannequin, and then here it should be, I believe it's in the it should be in the skeleton mesh. I don't know why I'm not seeing it. Oh yeah, blend profiles. So this settings icon right here, you go to blend profiles. I added this, and what you would do is for here, because you see how it has underscore weight, is that it is a weighted blend profile. So all you do is hit add, and then you would modify the values. So I just modified them accordingly in here to how they had it in GASP, although they were missing some of the bones and like sockets and stuff like that. So I just kind of filled in what I thought would be appropriate for those sockets. So as you can see here, this is what they're doing, is just weighting all the different bones and socket types for the character poses and like animations and stuff like that. So that's essentially like how you would do it. is by going here into the skeleton mannequin and then going to the cogwheel, and then in blend profiles, create a add weight blend profile. Because what they are doing, so now that we've taken a look at that, because what they're doing in here is, let me move over the game animation sample project, is as you can see, they have a fast feet plus root weighted blend profile. So if we actually take a look at that, so if we go into the skeleton of the UEFN mannequin and then click the cogwheel drop down and go to blend profiles that they have set, you can see that what they're trying to aim for is a more of a faster blend profile for feet and the root bone. So as you can see, like the foot root is weighted heavier because they want faster blends and animations there. And then the root blends faster. And then if we go down through here, you can see here that the left thigh and stuff like that are set at heavier weights because they want those to activate faster. So with the fast head, what they were doing there for the aim offset is they add more weight to the head so that takes over more than the rest of the body. So that's how you would do there. So that's why I said, like in the previous video, that I was going to do it behind the scenes, because it's just a very tedious task to do. So that is what they are doing there. So that is the only thing I just don't have in this video to show y'all is that, but that was pretty much kind of a brief rundown of what they did. So now that we've discussed that though, let's go ahead and get into the motion matching node and actually create our functions that we'll be using for this, and go over my notes for these different functions. So what we're going to do is we're going to go over here to functions, and we're going to hit the plus icon, and we're going to do the get underscore motion matching, believe it was blend time, just like that. And now what we're going to do is we're going to go to our variables and our states, and we're going to grab a get movement node, and we're going to want to switch on the movement node. So just like that, because we want to determine whether we are in the ground or on the ground or in the air. And then if we are on the ground, what we're going to do is we're going to get the movement mode's last frame, and we're going to want to switch on this one as well. So I am going to go over my notes with these, but for the moment, I'm going to go ahead and put the nodes together. So then once we have that, we're going to add some return nodes. So just like that. And we're going to add outputs now, and we're gonna make them floats because these are going to be our blend times. So we're going to call these outputs return value, because that's what we want to do, is we want to return those values. And because also too, these are going to be pure and thread safe functions, so we do need to get the blend times. So for this one, we're going to call 0.4 for our float, and then we're going to copy this and put it here. So when we are in the air, what we want for our return value is 0.2. And then what we're going to do now is, if we're in the air, what we're going to do is we're going to grab a branch node, and the condition for our branch is going to be if our velocities, so now we have to go to essential values and grab our velocity, and we need to split the velocity because we want to get the Z velocity, because that determines whether we're in the air or not. So off of the Z velocity, we want to get a greater than node, and we want to set it to 100. So greater than 100, and we want to plug it here into the condition. So just like that, and I'm going to stack them just like so. And then we're going to get the return nodes and place them here, and hook that into true and hook that into false. And so our true value is going to be 0.15, and then our false value is going to be 0.5. So essentially, to go over the dev notes real quick for what this is doing, right? So this entire function, because now that we're done with the blend, we're going to go over the notes. So the dev note is that this function is used to change the blend time of the motion matching node, and is based on the current and previous states. In the future, we plan to allow blend times to be more directly set from the chosen databases. So the way I was able to transcribe this is that this function is used to dynamically adjust the blend time of animation transitions based on the character's movement state changes, such as landing, jumping, or being airborne. It ensures smoother animations, avoiding abrupt changes by selecting the optimal blend type for each scenario. So essentially, if we do a switch for our movement mode to on ground and appear on our last frame on ground to get this 0.04, basically what this path is doing is when the character is already on the ground and remains grounded, the blend time can be slightly longer. This scenario suggests the character is moving while staying on the ground, for example, walking or running. Then if we go from on ground, or if we went to and our last movement or our last frame was in air, so for here our blend time is, that for the notes that I have, is when the character lands from an in air state, a shorter blend time is used to make the transition feel snappier. If the current movement mode is on ground and the previous movement mode was in air, this indicates the character has landed, and that's why we have a shorter transition, because we want to transition into our on-ground animations, or blend into our on-ground animations. So then with our in-air switching for our branch node, so for true is when the character jumps, the transition needs to be fast, as jumps tend to have a sudden upward motion. If the current movement mode is in air and the z-axis velocity is above 100, the character is jumping upward. So we need to be able to quickly blend into our jump animations when we do that. So that's why we have a lower value here, so that way it doesn't feel snappy or poppy into our jumping animations, or blending into our jump animations. Then for the false is that when the character is in the air but not rapidly moving upwards, so like falling or floating, the blend time is longer to create more natural feel. If the current movement mode is in air but the z-axis velocity is below 100, or the character is falling, the transition is not as urgent. So that's why you have like a longer blend time, when falling down, and how he does the looping or whatever for his animations. And then when we fall, how we do like that sudden transition into like, the fall down, like heavy, just landed light, just landed heavy, and we slowly blend into, our upright idle character position, or whatever position that we have or plan on using. So that is pretty much it for that part. So let me go ahead and copy the notes that I have set for these. So this is pretty much the default dev note here. If the movement mode is on ground but the mode last frame was in air, the character must have just landed, therefore a shorter blend time for the land animations. And then for this one, missed it by here. Alright, just like that. And so if the movement mode is in the air and the character is moving quickly upward, the character must have just jumped, therefore set a very short blend time for the jump animations. So now that we got that, what I'm going to go ahead and do is put in the bigger node, like so. And I just almost barely got it. And so now what I'm also going to do is, just so y'all can see my notes, I'm going to copy my comment bubbles here, because this is how I separated them to know like what each part is doing what as I went down in order. So this is basically my notes that I was reading from. So now that we got that, I'm going to compile and save it. And now we can go back into the first we have to turn it into a pure thread save function. So turn it into a pure and thread save function, and then we're going to compile and save. And then back in the anim graph, we can now, for our blend times, go ahead and bind it to the get blend time, just like that. So now that we got that, we can go ahead and work on the next part, which is updating our motion matching. So let me go ahead and do this too, just to get it cleaned up. Is for the under the get blend time, I'm going to do motion matching, just so I can get that category started. And now let's go ahead and create a new function called update motion matching. Just like that. And now this one everybody should be pretty familiar with because you'll have seen it in other motion matching videos, you know, from other YouTubers where they go over the basics of it, but maybe not in this light. What they would have done is they would have clicked into the motion matching and set it in here. Ah, this is where it is. Just didn't look into it. Oh well. But they would have gone into that and set up what we're about to set up now. So what we're going to be doing is in here, we're going to grab and pull out, and we're going to get an evaluate chooser. Because here's where we want to grab our chooser table that has, if I go back to it and go into characters, UEF and mannequin, animations, and motion matching data, we want to grab this right here, the pose search databases. So here, what we're going to do is we're going to grab right here the chooser table, pose search databases, and we're going to reference our self in here, or make a reference to self. Or at least it should allow me to, unless I need to change this first. I will come back to that in just a moment, but basically what we're gonna do, oh yeah, because the ABP sandbox character, so that's right, because it's referenced in our mannequin. So we will definitely be making a change to our Manny, where we will be putting him up against with the ABP sandbox characters, since we did migrate the sandbox character. So, but for the moment, we're going to ignore that. So basically what this is doing is that this evaluates a chooser asset, you know, called the chooser table pose search databases, to get an array of pose search databases that are relevant to the current gameplay context. So basically what it's doing is it's grabbing the two or all the chooser tables that are in this, because in the pose search database you can see how we have the dense table and the sparse table. Let me move that out here. That this is going to essentially loop from, and that's why we change it to all results, because we wanted to get all the results or all the databases so we can go in between all of those databases to get the appropriate animations. So now what we need to do is, within our motion matching, we need to set up two variable types. So we need to grab, where is it, the input, and we need to do a context. And here we're going to change it from a float to an anim update context, just like that. And then we're going to add another input, and we're going to call it node. And here we're going to get the anim node, and I believe it is reference, if I remember correctly. Yeah, anim node reference. I got a spell. Yeah, right here. Anim node reference. And that's how we set it up there. So now what we need to do is, off of the node, we need to get the convert to motion matching node, and we want the green one right here. So essentially what this is doing is that it converts the character's state and gameplay context into a motion matching node, which holds animation data and parameters for motion matching. So that's what this is doing, is just it's getting our state and updating it accordingly to our, you know, our animation assets stored in the databases. So then what we need to do now is we need to get a set databases to search. So basically this one right here, and we want to plug in the execution pin into here, and then the results into the array of databases for this, and then the motion matching node into here. However, now what we need to do is we need to create an interrupt mode. So a lot of times what you'll probably have seen in the other YouTube videos is, you know, interrupt on database change or stuff like that. But what they have done in here is they've created their own motion matching interruption function that will interrupt the databases to make the appropriate changes to the animations, you know, depending on the state of your character, or at least what it chooses in the chooser table. So What we now need to do is we need to create that function. So let me go ahead and move the update motion matching there. And we need to add a function and call it, oh, it auto saved on me. We need to call it get underscore mm interrupt mode, just like that. And this one, it may seem kind of big or long in the game animation sample project, but it's actually pretty simple. So let's go ahead and go through that. So essentially what they're doing is they're grabbing all of these except the rotation mode and seeing what is actually updating, because in the motion matching database, you'll notice that in the dense and the sparse, how they have the four major ones set up. Like the movement mode is set up as a column, the movement state is set up as a column, the gate's a column, and the stance is a column. So what they're doing is they're trying to check these individual states. So for example, what we're going to do is let's go ahead and go through this so you can see, right? So here we have a movement mode and the movement mode last frame, and then we have the movement state and the last frame of the movement state, and then the gate last frame. Move that out of the way. And then stance, and then the stance last frame. So basically what we're doing is we're checking to see if these are not equal to each other. So what we're going to do is we're going to look for a not equals enum and get this for all of those changes. I did not mean to do that. So, and see if these all are not equal to each other. So go ahead and plug them in accordingly. Just like that. Just trying to clean it up real quick. And then what they're doing is they have an OR boolean here because it's a bunch of OR exceptions. So they've plugged in the OR booleans, or plugged these into the OR boolean here. Just like that. And then we're going to grab another movement node. So I'm going to copy that and put it down here. And here we have an equals enum. And we're checking to see if we equal on the ground. So here we're going to do off the OR and boolean. And plugging it into there. And then off of here, we're getting the OR boolean. And plugging that into there. And then we're going to do a select node for the, let me double check. Yeah, so go ahead and hit, oh, come on, hit select. And we're going to plug it in there. And we're going to change the pen type. And I believe they have it set. Bear with me just a moment, guys. I'll be right back. All right, guys, my apologies. I am back. So I could not find this variable type anywhere that I looked, which is the ePose search interrupt mode type. So what I do have to do is I do need to do a little bit more research on that, because for some reason it just would not pop up anywhere in my template. So I don't know why that was the case. So I ended up copying this from straight from the game animation sample project and pasting it over here, just so that way I can kind of press on with the video for y'all. But when I do find out how to get it, I will put that in the description for, you know, this little mess up. So I do apologize for that. But you know, to continue on with the point that I was trying to make earlier, so now what we're doing here essentially is we're checking to see if the movement mode does not equal the last frame, or if our state does not equal the last frame, or our gate does not equal the last frame, or our stance does not equal last frame, and if we are on ground. So if we are on ground and any of these are true, then we pass it through here. And then if this is not equal to each other, or both of these slots are true, then what we're going to end up doing is we want to interrupt on database change. So that is essentially what we're trying to do, is just checking to see if we are, you know, either on the ground or we've transitioned into the air, or if we currently equal on ground, but any of our states are changing, the gate's changing, our stance is changing, to where we get true on any of these, you know, motions, and then we will interrupt on the database change. So it is a pretty unique way of doing a change compared to like simple ones you may have seen on like other YouTube tutorials or whatever for motion matching. So it is pretty interesting. So now that we got that, basically to just kind of go over what the devs have for it, is that the, you know, this function controls the interrupt mode of the motion matching node. You know, determines whether motion matching will force a blend into a new database if the selectable databases have changed, or wait until it finds a match that costs less than the currently playing animation. By default, we do not interrupt. However, whenever a core state has changed, we know we want to start playing a new animation, therefore force an interrupt. This prevents motion matching from sticking in the idle if the character has started moving, or staying in a cycle animation if the character wants to stop, which can happen based on the continuing pose bias tuning. Essentially, this keeps the motion matching responsive to changes in core states. You know, similar to kind of what I was telling you about, where it's like when we try to make any sort of like change to our, you know, movement and whatnot, that it will appropriately interrupt the database and make those adjustments. So let me go ahead and move these over and into here, and then move that into here, and we pretty much got it. So go ahead and move that back to group movement, and we just got to make sure it's pure and thread safe. So pure and thread safe, I had already checked those off when I was trying to search for this the interrupt variable. So now that we got that, we can go ahead and plug that into the interrupt mode type. So when going back to it, this essentially retrieves the interruption mode for the motion matching node, which determines how and when the system should interrupt the current animation. For instance, transitioning between like a walk or run, or, you know, a stop to a jump, stuff like that. So let me go ahead and grab my comments for these real quick and put them in here, because we also now have to talk about the set database to search as well. So actually, I can just go ahead and do this. And just like that. So now, as far as the set databases to search, essentially what this is doing is that the selected databases are then passed to the motion matching node to guide the search. This ensures the selected animation databases are dynamically updated based on the player's actions or environment. This ensures the selected databases respect the interruption mode, making sure transitions are smooth when switching between states like walking, running, and stopping. So now with that being said, we can go ahead and add a return node, and we've essentially completed this function. So let me go ahead and add my big comment bubble. Oh yeah, and I do have to add this one here. Just like so. And there we go. So now we are officially done with this function. So we can go ahead and compile and save. And then if we go back into the animation graph and go to our motion matching node, on the update, we can now should be able to give it, or at least I got to make it into a pure thread safe function before doing that. And back into the anim graph, we can give it on update. What was it? Oh yeah, we can't make it pure. That's what it was. We have to make it thread safe, but not pure. So now we should be able to select it. Oh, whoops. Hang on, guys. I'll be right back. Alright guys, I'm back. My apologies for that. I am sorry for all the cuts that I've been doing in this video, as stuff is just not working, or at least I'm kind of forgetting, you know, stuff that I did previously in order to get this video set up. So what I ended up doing was, on update, what I did was I went to motion matching and I created a binding, and then I just renamed that binding to update motion matching, and then just copied and pasted you know, the stuff that we did in the other function into here, just to at least get it working and going. So I apologize for all those edits that I've been doing throughout this video in order to get stuff working. So but other than that, to continue on with that, now what we need to do is, on motion matching state update, what we need to do now is create a new binding in here. And what we'll be doing is we need to get just a few nodes for this. So I'm going to move this out of the way, because this is where we actually do the current database selection for our variable that we've set up way long ago. So I believe it was up in essential values. Yeah, right here, the current selected database for our post search database. So here what we're going to be doing is we're going to grab off the node and get a convert to motion matching node. And we want the green one, the pure function. It's like I'm a bit trigger happy with the fingers. So we want this one specifically, because this, like how we mentioned previously in the other, the main update function, is that it converts the function state into a motion matching node context. And then what we want to do is we want to drag off and get motion matching search result. Because off of here, what we want to try to do is extract the result of the animation search performed by the motion matching node. So then off of that, what we want to do is we want to get, what I did was I changed this to get a break, because what they did was they split this. And so just to make it kind of look cleaner, I wanted to do a break instead. So what we want out of this specifically is this selected database, because when we convert the state's function into a motion matching node context and then we extract those results, we want to get whatever database is being selected and played for those animations. And we want to set that into our set current selected database variable that we had set up way long ago. So another reason why I did this break too is just that way I can hide all unconnected pins just like that, so it just looks nicer. So once we got that, we can go ahead and on state exit, or right here off of our start function, we want to plug that into the set, and then off of the set variable into our return node, just like so. So now let's go ahead and rename it. So we want to go back up here. Let me go ahead and close that down. So I'm going to rename the on-state exit to the update motion matching underscore post selection. Oh my goodness. All right. Post selection, just like that. And then let me go ahead and grab my comments, because now we are going to talk about the current selected database one real quick after I put my stuff into here. And let me move this over briefly. All right, just like that. So now with the current selected database, what this is doing now after we get all those results is that the current selected database variable allows the system to cache which database the selected animation came from. This is necessary due to thread safety issues where certain data cannot be accessed safely across multiple threads, so it's cached to use in the event graph when needed. This ensures that the database containing the selected animation is accessible later. Without this step, the system might run into multi-threading issues when trying to directly access the database in real time. So they have this set primarily for thread safety concerns, so that way we can safely run these on like the game threads and stuff like that, and not at like a performance loss or anything like that, or cause corruption somewhere, that kind of stuff. So to just briefly go over what we did is that for this function is that it's responsible for caching the selected animations database so that tags or other metadata can be accessed safely. Thread safety issues arise because Unreal Engine performs certain operations across multiple threads. If you try to access data directly, it may not be consistent or could cause conflicts. Caching the data prevents this problem. So, what they've said is that in the future, this function might also adjust blend times or blend profiles based on the animation that was selected. For example, if the selected animation comes from a sprint database, the blend profile might differ from one used for walk animations. So now that we've discussed that and got that created, we can go ahead and put this comment bubble in, and we can go ahead and compile and save. And I believe they also, they have it, should be a thread save. Yep, thread save function. So now that we got that we can go back to the anim graph. So now we have the motion matching node set up, where we have the update motion matching function and the update motion matching post selection and our blend times. So currently right now, this is not going to work if we try to plug it in, because as you can see when we go into, I believe it is, up here, we need to tie this to self, but it's not letting me do that because it's trying to call the ABP sandbox character, because however this chooser table is being selected or is tagged, for some reason it's calling the sandbox character. So we do have to fix that to call our ABP Manny. But other than that, this is essentially what I might end up essentially doing is changing our ABP Manny into the sandbox character, or at least just more or less going over it and discussing it, or I'll provide a fix and do that update in the next video. But other than that, we have our stuff set up. So again, we can't use our apply mesh space additives just yet, just because now we still have to do other stuff. So when we go into the motion matching node, so when I pull over the game animation sample project, is that now we're going to be working on the individual component parts, where we go over what orientation warping does and what this steering does with this get desired facing function, and then what this steering is doing by using the current selected database that we're caching in the post selection, and checking to see if the tags equal turn in place, and all this other stuff. So this, depending on how much I get through my notes and how long it could potentially take, these will probably be individual episodes, or my next video could end up being a finale if this isn't as bad as I believe it out to be. So other than that, that is pretty much it for this video, guys. And once again, I greatly apologize for all the edits that you see throughout this video. It's just that when I tried going over this briefly on my own, it looks like I just forgot certain steps, so that's why I had to research for those steps for a moment, just so that way I can give you all the proper output and guidance of what we're doing. So I apologize for that. So other than that, guys, if you enjoyed the video, found it educational, that's great. That's awesome. I hope you check out my other videos and my future videos to come. But other than that, guys, y'all have a great rest of your day and take care.